This is part 2 of Module 6 for 1121. This section goes through topologies, and I talk about topologies, just the physical layouts or the logical path that the data takes to get from point A to point B. So let's take a look at some topologies. Maybe. There we go. Physical versus logical. It's pretty straightforward. Physical topology, how is it actually wired? In most cases, we're going to physically wire them as something called a star. Every once in a while, they can be a bus, and we'll look at each one of those. But most of the time, we're going to have what's called a star, and then we'll have some other topologies that extend off of the star, like the extended star. And even though really when you map them out, it doesn't always look like a star. Like if you looked at one of the regular classrooms and you said, "Hey, what's the physical topology of this?" and you said a star, you'd be like, "Oh, okay." So in our classroom, we've got we've got all these seats that are listed here, and they're all next to each other. And what you're saying is we got 2 rows. Remember? You guys remember what classrooms look like? I know. But we got 2 rows of desks, and in those desks, and they would say, okay, well, the physical topology is a star. Oh, okay. So how does that work? Well, it means that there's a cable that connects each one of these computers into a switch, and it kind of looks like a star. Now, in reality, it doesn't look like that, right? It doesn't look anything like that. The desks are all next to each other, and they all run their own cables into the wall at the side of the room, and then they go up into the ceiling, and then they get run over into a data closet, which goes to a patch panel, which actually runs where it's supposed to go. So it really kind of looks like this. If we wanted to really draw it out in real physical form, it's a whole bunch of cables that just kind of show up over here, and then they all get bundled together into a ceiling, and they all just go up in here, and then they end up at a patch panel someplace else, and that's what it really looks like. So physically, it doesn't really look like a star, but it is known as what's called a logical star because it is formatted that way. Okay? So just a little bit on that. No big deal there. Types of topologies that are out there. One of them is called a point-to-point. Another one is called a hub and spoke. And another one is called a full mesh. Pretty straightforward. We'll do point-to-point first. Point-to-point's on the next slide. And take a quick look at point-to-point. And point-to-point is listed here. And it just shows you that, when you're in a point-to-point network, even though there's a cloud here in the middle, a couple things. Logically, the IP address here, or the network address here and here, going to be same network. Same network. Same network for this and for this. These 2 guys are going to be on the same network. Secondly, there's nowhere else to go. This is, even though it's going through this cloud system, there's going to be a direct connection between these 2 devices at layer 3, and they're going to be what's called point-to-point, which just means this. It means that everything that node 1 sends can only end up at node 2. And anything node 2 sends can only end up at node 1, and that's all there is. What's the advantage of this? Well, we were talking about frame headers a little bit in the last set of slides. What it means is this, is that if there's only one other device that you can go to, the layer 2 address can be generic. It can be a generic value like calling someone dude or guy, or something like that, because it doesn't matter. You're going to send out this frame header, and the frame header is only going to end up at the other side. So it doesn't matter if you use their formal name or if you use just a name of like router or device. It's not important. So just keep that in mind when we talk about point-to-points and how they work. Point-to-points are becoming less and less usable or used on the internet. Okay, next slide gets into LAN topologies. Got a local area network. Now, the worst thing that we could do with a local area network is run into what's called a mesh system, which is coming up next. But we're going to look at the functional way of how these things roll. Is we end up in these stars, which we kind of already did a picture of. And anywhere you see kind of like the point of a star, like here or here or here, anywhere I've drawn a little circle, you can just consider that to be a switch. A switch would be in that particular location. Switch is here, and the switch is there. And those are all switches, and the switches are going to create that ability to have what's called multi-access. And in multi-access, it just means this. I got one card. I've got one network card, and I can access many other devices through that single card. And that's what they're getting into when they get into this star physical topology. Okay. Another one of those topologies is what's called the bus, where everything's daisy-chained together. Used to be popular, not as popular anymore. Kind of the Christmas lights theory. If we have a break in this here, I guess red would be cooler for that, right? Hey, if we have a break in this here, then no one can talk and everybody's upset. This is all very, very bad. Not happy. So we're not a huge fan of buses anymore. Ring topologies, there's still a couple ring topologies around. There was something called token ring that was available many, many years ago, token ring, and it competed for your LAN dollars. Physically, it would set up as a star, but logically, the way it worked was, in order to send data, there would be a device that would have a token. It would have the ability. It would time slice in and say, okay, hey, device A, it's your turn to send on the network. Do you have anything? And if device A had anything, they had X amount of time to send stuff. And after that time period was up, they had to wait. So if they had more stuff, they had to wait for, B and C and D and E and F and G and H to all get the token before it came back around to A again. And A's like, hey, wait a minute, I got more stuff. I'm going to send more stuff out on the network. And then it would run out of time, and then it would go back all the way around again. So it was a time-sharing component that was called a token ring. And the token was just the time slicing that there was really no token. It was just the time slicing that was available. And there was a device called an MAU. We used to call them a MAU. And the MAU would then tell which device, hey, by the way, you have X amount of time on the floor to send what you want. And when that's done, you're going to stop and you're just going to hold back whatever else it is going to send. This was a good system. Unfortunately, it maxed out in a copper method. At, as I remember it, now this could be, Mbps, at about 15 megabits per second, and that was as fast as we could go on Token Ring when we installed them. Oh my gosh, a really long time ago. So Token Ring kind of went, we're not going to use that anymore. And the Ethernet technology, which would go 100 Mbps or 1,000 Mbps, and even 10,000 Mbps and faster became the new standard, and it did not use a token, but it used contention. Basically, within Ethernet, we're getting off subject a little bit, but within Ethernet, if you had information that you wanted to send to the network, you just sent it and then hoped that it made its way to the destination based on the switch doing its job. And in the next video, we'll actually talk about how a switch does do its job. So don't worry too much about Token Ring. Know that it was there. Bus systems, know that they were there. Know that everything's called a star, even though it doesn't really look like a star. And that's the main things we're getting out of this particular slide. They do bring up just one or two. I think there's just, what else do we have here? Oh, CSNA, CA, and CD. Two more things in this section. Number one is half duplex versus full duplex. Very simply. Full duplex means that you can send and receive stuff at the same time. Half duplex means you could either send or receive at the same time. Half duplex is pretty antiquated. A switch will allow you to send and receive information from a device to another device at the very same time. There was a device known as a hub that we used before we had switches, and it was a half duplex solution. So you could only send or receive at the very same time, and that was a much slower technology. So it's been years and years and years and years since switches came in, like around 2000, 1999, 2000, somewhere in there. Switches replaced most of the hubs. So we've been at full duplex for quite a while. So we can just send and receive at the same time. Pretty soon, we're going to get into a system where we're going to look at all the cabling wires. We're going to talk about exactly how that works, sending wires versus receiving wires versus wires that are on power versus wires that are set up to identify collisions. We'll do all that in a different presentation. The last slide in this section, though, talks about two things, something called CSNA CD and CSNA CA. And these are the predominant methods that we're going to use to move data on lands. Okay, now CSMA CD stands for Carrier Sense Multiple Access. Carrier Sense Multi-Access is at CSMA. What that means is this, just two things. Number one, when a machine wants to send information to another machine, the first thing it's going to do is check to see if there's a clean path to the next device, right? So if I'm on a PC and I want to send to another PC, I'm going to have a connection here and a connection here. I'm going to have another PC over here, and I've got A, and I've got B. Now, that B is horrible. There we go. So if A wants to send to B, A has to check this line and see that no one else is sending on it. Now, here's the thing. In full duplex, you can send and receive. There's a send channel and a receive channel. So if you're not sending anything, no one else is sending anything, and the check is kind of a formality. However, in a half duplex situation, if another device was sending to you, you wouldn't be able to send back at the same time because it's half duplex. You can only send or receive. So you would have to check the wires. So you got to keep in mind, this is from a legacy point of view that, oh, I can't send anything right now because I'm receiving something. So that's where that carrier sense comes in, okay? Multi-access just means this. It means that I can use one card and I can access device B, or I can get to device C, or I can get to device D, all through a single card. So multiple access within the local area network, which is how they're all set up, right? So CSMA, carrier sense, check the wire, make sure you're not sending something else. Multiple access, can I access multiple devices with the same card? Absolutely. Now, the second part of this is collision detection. CD stands for collision detection, which is written right here. Now, this is regular wired Ethernet, uses collision detection. Now, here's the thing. Once we put switches in place, the switch will handle the communication between the devices, and it will say, okay, I'm going to go ahead and identify each one of these hosts that's connected to me, and I'm not going to allow their stream of data to interact with anyone else's stream of data, and we're not going to have any collisions, and we're not going to have any bleeding over of the data getting from one device to another when it's not supposed to. I'm going to hold all of these as unique connections, and I can make my own connections with this, and they're never going to touch each other, and they're never going to be a collision. So it's something you don't really even have to worry about anymore, collision detection. In the good old days, if somebody was sending you something and you didn't realize it and you started to send back at the same time, it would create a collision. It would create a collision, at which point the data that you were sending would be destroyed. And the data that someone else was sending would also be destroyed. And then you'd have to use this backup algorithm and then send it again. So that's where that CD stands for. You're not going to have to worry about that anymore because the switch is going to handle or manage all those communication streams, and they're never going to collide. So collision detection with the switch, once again, it's a formality. It's a method that was created when there were hubs in place, a different device that didn't manage the streams of traffic. Okay? All right, cool. All right, second bullet point, last thing we're going to talk about in this particular slideshow is CSMACA. CSMACA stands for CSMA, Carrier Sense Multiple Access, CA, Collision Avoidance. Collision Avoidance. Now, collision avoidance means this, that there's going to be a master device that's going to be controlling the devices that can send stuff. So in an example of collision avoidance, we could say something like this. Here's an access point, and here's a computer, and here's another computer, and we can have an A and a B on these. And what this device is going to do is it's going to say, okay, in this time period right now, A, you have the floor. Send me all you can for this period of time, for this time space. And then when you're done, we're going to ask you to stop, and then I'm going to ask B to go ahead and send what B wants to send. It's a lot like that token ring thing we talked about before, but it's just managed by an access point. So CSMA, collision avoidance, says this. We're in airspace. If A sends at the same time B sends, B's signal could interfere with A's signal and cause all of the signals to stop communicating with each other. And that would be really bad. So we have to have collision avoidance. The way that we're going to do that is we are going to allow that intermediary device to control the traffic based on frame space, based on, why isn't this working? Based on frame, well, I guess I'm not going to draw that back in there because it doesn't work. Oh, there we go. Okay, so now the access point is back in business, and it's offering this time slicing to these devices so that they can both communicate, but not at the exact same time. But we're going to do it so quickly, you're not even going to know that it's half duplexing, that it's going to seem like full duplex. All right, cool.